All right, problem 79. What is the domain of the function shown on the graph below? And that sounds like a fancy word, but a function is just a rule. It's just a rule that maps from one set of numbers to another. And the set of numbers that it maps from is the domain, and the set of numbers that it maps to is the range. So if this is a set of numbers, the domain, this is a set of numbers, the range. The function tells us how do we get from this number, someplace in the domain, to that number, someplace in the range, right? So in general, the domain is all the numbers for which this mapping or this function is defined. So in this example, oh boy, no, there's not enough space. Let me copy and paste it at the bottom of this thing. Now I have enough space. Okay, so let's see. So the domain is where is this function defined? So let's see if so this function is defined for x is equal to, and in general when you plot it on the xy axis, the domain is all of the x values that you're defined over, and the range is all the y values. So the function is a mapping from x to y. So let's see where it's defined when x is equal to 4. It tells us we're mapping from x is equal to 4 to y is equal to -1. So it's defined for x is equal to 4, for x is equal to 5, for x is equal to 2, right? X is equal to 2, and it's defined for x is equal to 1. So it's defined for all of those numbers. That's the domain. This function is not defined. We don't know what happens when x is equal to -2. It's not defined. It tells us no. It doesn't tell us what y equals here. So these are the only numbers for which this function is defined. It tells us that 4 maps to -1, 4 maps to -1, that 5 maps to -2, that 2 maps to -5, and that 1 maps to -4. That's all it tells us. And this is actually the range. That's the range, and that's the domain. That's the domain. So let's see. 4, 5, 2, 1. 4, 5, 2, 1, right? This is the domain. That's the set of all numbers for which the function is defined. This -1, 2, 5, and 4, this is the range right here. Right here. Choice B is the range. All right. I think we're on the last problem. This is going to be a lot of cutting and pasting. I don't know if it's going to fit. I have to shrink it. Okay. They said, which of the following is not a function? That's fascinating. Okay. I've copied it. And now I have pasted it, and it did all barely fit on this page. So which is not a function? And remember what I said in the beginning. I don't have space below here. Let's think about what a function is, and then we can look at the graph and it becomes. So a function is a mapping from one set to another, from set A to set B, where A is the domain and B is the range. And this is the important thing to realize about a function. So if this is set A, and if this is set B, that for any value in set A, it only maps to one value in set B. You cannot have this. You can't have one value in set A going to this value and going to another value. So let's see which of these. So that would not make it a function. You can't have one. If we say x is the domain, if this is the set of all values that we can put into x, and this is all the set of values that go into y, or that can be y, then one value of x can't produce two values of y, right? You can have it the other way around. You can have two different values of x producing the same value of y. And we'll think about what that is. So let's see. That's completely valid. Like you could have two numbers. When x is equal to 2 and x is equal to 7, you can still have y equaling the same thing. But you can't have x equal, say this is x is equal to 5. You can't, x equals to 5 could be y is equal to 7, or x is equal to 5 could be y is equal to 8. We don't know that. So let's see. Let's think about how we can visually think about this. So here, for every value, and for every value of x, we only have one definition for y, right? And people often call that the vertical line test. At no point on this graph can I draw a vertical line and it intersects it twice. If a vertical line intersected twice, that means for a given value of x, this function defines two different y's. Not going to happen. Now this function does for any given y have two different x's, right? For like that point and that point. But that's okay. That's completely fine. So for example, when x is equal to -1.5 and x is equal to 3, they point to the same number. So in that example, that's like, x is equal to -1.5 and x is equal to 3. They both point to the same number. That's completely okay, as long as one of these don't point to two separate numbers. So that magenta is what that first graph is doing. Same thing here. We have, for any given y, we can have two x's pointing to it. But for the vertical line, and this is fine. That's completely fine for a function. Now, when we talk about function inverses, well, I don't get too complicated. That's completely fine. But if we do the vertical line test, at no point can we draw a vertical line and get, for any given x, two separate y's. Same thing for here. Actually, here we have a complete one-to-one mapping. For any given x, there's one y. And I think here it should be clear that if I were to draw a vertical line, let's say right there, I have for one x, let's say for x is equal to 2, there's two. Actually, let's do it more interesting. For x is equal to 1, for x is equal to 1, it has two definitions. Oh, even better. For x is equal to 0, y could be minus 2 or plus 2. So that's the case that we said. For an x is equal to 0, it's pointing to plus 2, and it's pointing to minus 2. It's pointing to two different values, which you cannot have in a function. For a function for any given x, you can only define one y value. So this relation is not a function, D. Next question. I think this is the last. Gets a page on its own. Oh, that was the last question. Did I skip a problem? See, that was 80. Oh, I did 79. Oh, that's it. We're all done. All right. See you soon.